So these are the observed in case of this particular data analysis. So you have to be careful about that one. Just a second, please. Okay. So actually some problem with my slides right now. Just a second. Just a second. Actually, I do have some problem with my slide, so that's why I am unable to share with you. So let's go to the syllabus and we'll go through that one. Okay, you have to check the deviation for the mean and all the things. These graphs are there. Frequency distribution curves are there. So you have to check it out. This the all the mathematical things. So that's why that a symbolical representation is not possible right now. So that's why there is some issues. So thing is that you have to follow your that is syllabus. Okay, this is confidence interval. So that is so lots of things are there. So that's why that what why it is, as it is a mathematical area. So thing is that probability calculation and all the things you have to check it out from your side. If see that if addition, so this is a mistake, this is an error, okay, and it's a not error you can say, but it's a blunder. Sometimes what you will do, the addition will be that is calculation, arithmetic, general arithmetic calculation, that is addition, subtraction, or division. It might be that wrong, okay, but use all the procedure are correct, everything is correct, but the addition is mistake, there is a mistake in addition or division. So the value will be the value will be that actually the fault value will be there. So that's why careful that carefulness is important in this case when you are doing any kind of things. So sincerely you have to do this as it is the mathematical calculation area. All the things are mathematical areas are there. You have to go through this one analytical data too. Confidence of internal with a sigma is not known. If what will happen then? So all the things are mathematical values. So on the criteria of rejection of data, okay, criteria for rejection, what why the data is rejected, what are the 4D rules. See, the 4D rules is omit the doubtful value and find out the arithmetic mean of the rest. Okay, if there is actually if there is doubt, so just omit, don't take that doubtful data. Okay, so you have to take the mean data. So that is most important. If it is doubtful, so don't consider this one. This is you have to take the mean data. Okay, second, find out the average deviation of the rest of the values obtained after the omitting the doubtful values. If there is doubtful values, omit that one, rest, find out the average. That's the mean value. Okay. So things that next, whatever, this is the 40 rules. These 40 rules are important. Often the difference between the doubtful value and mean calculated value, what we have done already, that we have calculated already that one. So mean value xi minus x bar or x dash, already we have done this one. So that is on the basis of that you have to calculate it. Criterion. So if the difference of z value, z means that is the that mean calculated difference value. So greater than 4 times of the average deviation calculated, the suspend the value should be rejected, otherwise return it. Okay. So these are the things. The Q test, you have to know what is the Q test are there. Okay. Then quality test. Q test means quality test. Test of significance. So you have to go through this one, test of significance. These are all the mathematical things. The T test of the student and T test, right? So these are all the mathematical values. You have to check it out. F test, all the tests you have to check it out. So Z square test, all the tests. These are the tests you have to go through this one. On the basis of that, you can only calculate the reality or real value of this thing. So that's why that analytical data 2 is most important for the means experiments and all the things. So go through that one. I'll prepare the slide and I'll send to you. Okay, these are the summary, and so that's why I could not help you, because my slide is not working right now due to the mathematical that symbol and all the things. So that's why the most of the unit your unit 3 is completed due to that mathematical areas and all the things, and I'll share that what are the mathematical slides are there. So all of you got that unit 1 slide. Okay, that's fine.
Okay.
So now we have to go to the, so mostly this thing is, so we have to go to the next we have to go to the, just a second. Just a second, I am rejoining, so some issues are there. Just a second. Okay, so now the thing is that we go to the another area of a study, that is your neutralization titration, right? So while neutralizing, so thing is that uh, when you are doing any kind of a titration, that is another unit of study. So doing the titration, so that is means neutralization should be there. Okay, so it is important in case of that. So that's why it is neutralization titration in case of that is neutralization, that titration 1. Okay, in this case, what to do, that the titration or titrometric analysis refers to the quantitative chemical analysis carried out by the determining of the volume of the solution accurately is known as the concentration. Okay, if the concentration means you have to calculate the that amount is present on the basis of the concentration calculation. So it is maybe acid base, strong acid with weak base, weak acid with strong base. So many procedures are there. And in the objective, after the studying the unit, you will be explain the concept of a titrometry. What is what is the procedure that maintained in the titration? Explain the nature of the neutralization titration curves. Understand the primary and secondary standards. Describe the theory of indicators. Select the appropriate indicators for the particular titration and calculate the pH of acid, base, or buffer solution. So these are the objectives of this chapter. Okay. So now the basic concept of the titrometric primary and secondary standards. Okay. So primary standards of a titration. So what is the basic concept of a primary standard? So the primary standard is the substance which satisfies the following requirements. What are the requirements? It must be easy to obtain, to purify, to dry, and to preserve in pure state. This is the primary standard. So it should be, we satisfy the following requirements. The substance should remain unaltered during the aging. It should not be hygroscopic or oxidized by air or affected by carbon dioxide. It should means these steps should be followed. The substance should be capable of being tested for impurities by qualitative and other tests of known as sensitivity. Next, it should have high equivalent so that weighing error may be negligible. Next, the substance should be readily soluble under the experimental conditions. Next, the reaction with the standard solution should be stoichiometry and practically instantaneous. So these are the primary standard that titrometry. In the primary standard titrometry, that this should be satisfied. And if these 6 steps are not satisfied, so in the actually when you do the titration, that will be faulty one. So in case of a secondary standard, what to do? In the secondary standard, the substance which fulfill requirement that it can be weighed accurately to provide a known amount of a reactant, but which is not pure substance. So this is the secondary standards of titrations. Okay. So then we have to understand the titration curves. So titration of a strong acid versus strong base. If we take any kind of a strong acids like that sulfuric acid, hydrochloric acid or nitric acid, these are all known as the strong acids. So which can easily release H plus ions. Okay, and strong base. If we take the strong base, so ammonia is a strong base. Okay, right now ammonia is a strong base. So that or sodium hydroxide is a strong base. If we see the below the H plus ion, when you are doing the titration, the H plus ion.
Sir, skin is not visible.
Sorry, that is the issue. Okay, just a second.
Sir, yes, yes.
Actually, I'm Somen, that I was unable to share with the slide. Some problem is there in my system. So right now I'm just going through this one, but I'll share the slides. Okay, okay, that's good. So thing is that, so if we'll come across this strong acid and strong base, strong acid, as you know, that H plus ion release faster. So usually, if you will consider these things, so hydrochloric, nitric acid, nitric acid, sulfuric acid, these are the strongest, and rest much more oxo acids are there, which are strong acids. But usually in the reagent, I am telling you that in front of you that these are the strong acid. Strong base, the ammonium hydroxide, that the sodium hydroxide itself, ammonia is a strong base. Okay, so that's it. You will see that from the acid, H plus ion will come out, and from base, OH minus will come out. So that thing OH and H plus, so will make water molecules, and then what will happen? So Na plus, suppose here in this in front of you that one HCl hydrochloric acid, so strong acid, I told you hydrochloric acid is react with sodium hydroxide, strong base. Then what will happen? From hydrochloric acid, H plus will be released, and from base NaOH, OH minus will be released. So H plus and OH minus will make the water molecule as a product, as you seen in the screen. So water molecule as a product. Rest part, what is there? There Na plus is there. In that base part, Na plus ion is there, and in the acid part, Cl minus is there. So Na plus and Cl minus will react, and they will form the Na plus and Cl minus, that is the sodium chloride salt. Okay, these are the simple titration method. The H plus in the written there, the H plus and OH minus combine to form the H2O, and the other ions Na plus and Cl minus remain unchanged. So there is no formation of that. So the net result of neutralization is conversion to HCl to a neutral solution of a NaCl. Okay, so that means NaCl, now that NaCl both are the product will be, that NaCl will be there as the neutral product, neutral that it will dissolve in that. So the calculation of the titration curves involves computation of the pH for the concentration of the particular species at the various stages of the titration. The pH during neutralization process will be calculated as follows. So pH, the calculation of pH should be there. Okay, up to the equivalence point of the pH of the solution is determined by the amount of a strong acid remaining present. What are the amount of a strong acid present? On the basis of that, we can calculate the pH also. At the equivalence point of pH is 7, that means neutral. pH 7, as you know that pH 7 is less than 7 is acidic, and more than 7 is basic. So after passing the equivalence point, pH value is defined by the excess of the base. So now the thing is that, see, that when that initially it will measured, so the hydrochloric acid strength of hydrochloric acid will be more, so then acidic will be the pH. Then at the equivalence point, when the reaction is completed, equivalence point, both sides is reactant side and a product side, no further movement. So what will happen? The pH will be the 7, which is a neutral condition. Okay. So after that, that pH will be moves towards the base. So these are the simple titration of strong gas and strong bases. So if you come to the graph, this is the important part of the your study. You have to study this graph very accurately on the basis of, because this is the just a second. This is the graph where you can see that neutralization curves 100 centimeter cube of HCl with NaOH. So that is value is 100 centimeter cube, and HCl with NaOH of the same concentration. Okay. Now the initially in the below part of this curve, below part. So 1 molarity, 0.1 molarity, 0.01 molarity of a strength is given, and at the point, so 4 to 11, if you curve 4 to 11, so that means complete the three things are going on the same page. That is the neutralized area. Then after that, so which one is the 1 molarity? So that is again 1 molarity, but it will touch in the top part of that, and pH is 14. Okay, so here is the 0.01 molarity, so that it will middle part, the pH is the 13, and the 0.01 molarity, the pH is the 12. So here in the initial pH is 2. When the pH is 2 of left below part of the curve, 0.01 molarity, so that means that its pH changes into the 12, right? So means higher here, the more towards the base. 0 to 2, it's moving towards the base. That is neutral condition, towards moving towards the value of the pH is more. So here in this case, what is that? This case of whose pH is 0, that pH is in the latter stage, pH is more, right? So that's why this is the calculation of that one. When if the pH is less in some chemicals, pH is very less, so that will after the product formation, after the completion reaction, that pH will be more. So the component is like that. If pH is high, then the pH will be in initial stage, pH is high, so that means pH will be go down in the after the production of formation, product formation. So this is the reaction that basis you can understand of that one. Okay. Next, if you come to the point, this is the estimation based on the kinetic and acid base equilibrium studies. So as you know that chemical kinematics or chemical kinetics is an important area of this analytical chemistry. So how to calculate, and that application of log and all the things will be there. So it is an important area of calculation. So suppose that's then after 50 centimeter cube addition of sodium hydroxide, the solution 50 centimeter cube of unneutralized acid will be present in total volume of 150 centimeter cube. This is the area. So now understand the concentration of acid is 50 into 1 by 150 m. So that is the 1 by 150 total volume. So that means 50 by 1 by 150 molarity. So that means P around 0.33 m, and it will convert to the pH is 0.48. Okay. So like that you have to calculate. Base you have to calculate. After 75 centimeter cube addition of sodium hydroxide, H plus what will happen? 25 into, because that value of that 75 is 3 times. So 25 divided 175 is equal to 0.84 pH. So on the basis of this, you have to calculate the, that is chemical kinematics. Okay, now we'll come to the titration of weak acid versus strong base. Weak acid versus strong base. As you know that weak acid means, suppose if you will take the example of acetic acid, that is ethanoic acid, CH3COOH. It's a weak acid because that the pH value is around 6.5, 6 to 7 in between that, because I told you different several times that it depends upon the quality of the fats. So quality is a factor. So it depends upon that quality. So lab, that is if it is acetic acid, it is 5.7. Lab, if we test the lab acetic acid, it is a 5.7 to 6.2 in between that. But if we usually what acetic acid we are taking, or vinegar you can say we are eating, so that is the range is 6.5, 6.34 to 6.78. So it depends upon the quality of that acetic acid. So that is a weak acid. Okay, weak acid means the H plus ion will release very late. It will take, and hydronium ion when it will form, it will take much more time. Okay, so weak acid and versus strong base. If we take the weak acid, that is ethanoic acid, and strong base, as you said, sodium hydroxide, if we take the strong base, so that means CH3COH and NaOH plus OH minus. Again, H2 will be formed because acid will release H plus and OH minus will release, so H2 will form. Then Na plus and CH3CO minus, which will give the sodium acetate further. Okay, so these are the reaction that sodium acetate, that acetate ion is there, acetate ion is there, and sodium ion is there, right? So acetate ion will give will react with the sodium, and then it will sodium acetate will be it will be formed. So CH3COH is known as Bronsted that base, and this is acid, Bronsted acid. So that on the basis of that, so reaction will be conducted, and on the basis of that, you have to calculate the things. Okay. Next, I told you as that calculation is depending, pH calculation is depending upon the acid. So log table also. So you should have some log value also. You should have understand some log value also. So if pK value increases, so that means that is that pK value increases means acid strength. So pK value increases means acid strength decreases. If pK value decreases, acid strength is increases. pK value increases, acid strength decreases. pK value decreases, acid strength increases. Like pKb value decreases, base strength increases. pK value increases, pKb value increases, base strength decreases. So it is in that what is that? Inversely proportional to each other. So as I told you the earlier that a log table is essential. So pH is find out half of a pK minus half of log acids. So you can calculate the pH like this. So half of pK value minus half of log acids. So that means it is the find out the weak acids. Okay, on the basis of these are the formulas are there even, so you can find out the what is that all the strength of what is that acid and a base and a pH values also. Next, now come to the point, titration of a weak base with a strong acid. A strong acid, strong base, then we have choose weak acid, strong base, then it is weak base, strong acid. Okay, again that I told you that ammonia is a strong base. Okay, ammonia is a strong base, and hydrochloric acid is a strong acid you can take. In this example, that is also explained here. So ammonia versus HCl. So when ammonia versus HCl, it will gives NH4 plus, means ammonium ion plus Cl minus. There is a dirty bond in here, NH4. Dirty bond is there, as the lone pair is present on nitrogen in NH3. So it is a lone pair is present. So that lone pair will be donated to the, means there is a bond between the hydrogen and the nitrogen, and one electron will be donated by that nitrogen and to the hydrogen, and then similar the bond will be formed, NH4 plus having a dirty bond and Cl minus. Further it will make the ammonium chloride. So that is a salt. Ammonium chloride is a salt. So this is actually, this is a that what is that weak base, strong acid. It's a acidic salt. If the which value is more, suppose in case of a strong acid, strong base, that strong acid, strong base means the salt will be form neutral salt. Weak acid, weak base, the salt will form neutral salt. If the acid strength is more and base strength is less, then that is will be formed by the acidic salt. If the base strength is more, acid strength is less, then it will be what is that acidic basic salt. So here both are what is that strong base and strong weak base and strong acid. This is as strong, that acid is used, weak base is used, so it is the acidic salt. So ammonium chloride is an acidic salt. You have to understand that what kind of a product will be formed on the basis of a reaction. So that's on the basis of that you have to fix the experiment, what type of reagent you have to use. Okay, so that means it will give the that is the format of, again that is the pH of the solution of a weak base. I just told that pH of the solution of weak base. So pH of a pKw value minus, it's a water value. pKw means water, potential strength of water, minus half of pKb value, base value, plus half of log base. So strictly you can say this is pKw divided by 0.5 or whatever the value is there. The pH of the equivalence point is there. pH of the pKw means water, potential strength of water, minus pKw pKb plus log base by salt. So that means what I mean to say, so logarithm should be, you should understand the logarithm and its properties, how it behaves, what is the value of logarithm. You can use the table and also all the things. Okay, but you have to understand that logarithm, how the logarithm calculation will be done. Next, the titration of weak acid versus weak base. So I just told you, strong acid, strong base gives the neutral salt. Strong weak acid, weak base, neutral salt. Strong base, weak acid, basic salt. Weak base, strong acid, acidic salt. So this is the neutral salt which will be formed. So if we take the strong, any kind of a strong acid or that is weak acid and weak base, any. So here you can take the ammonia as a weak base, and that is which one? Magnesium hydroxide will be the weak. Weak acid will be acidic acid. You can take, so you can do the experiment also like that. So these are the things, and now the thing is that titration of sodium carbonate versus strong acid. So sodium carbonate is a Bronsted base. So that is a primary standard of the standardized of the this kind of actually this kind of a titration you have done or not, I don't know, but so thing is that this kind of a titration is important. So carbonate ion will react with the water and will give hydrogen carbonate plus OH minus. So this is the reference things you have to understand, right? So if it is a strong sodium carbonate Bronsted base and a strong acid will provide the H plus, right? And that will be react with the CO3 means carbonate ion. So HCO3 is formed and OH minus released. So that's why it is the another type of important reaction in this case. Okay, if we next move. Okay, so titration of a polyprotic acid versus strong base. So that is protic acid. Protic acid means that H plus ion. Suppose if we put the hydrochloric acid into the water, so it will give hydronium ion and Cl minus. So one H plus is it's a monoprotic. If 2H plus will means sulfuric acid, if will that it will react with the water, so adding the sulfuric acid to the water. So probability of chances of either it will be release 1H plus or 2H plus. If it release 2H plus, then it is diprotic in nature. If it release 1H plus, then it's monoprotic in nature. So that's why on the basis of that, you have to understand whether that this thing is that a monoprotic or a diprotic or anything else. So that polyprotic acids, how the polyprotic acids versus strong base will be, polyprotic acids versus strong base will be done. So diprotic acids can be titrated stepwise. Diprotic means 2H plus ions. I told you 2H plus. Suppose sulfuric acid, you will treat it with water. 1H plus as a reactor, 1H plus is released. So the product will be there that H hydronium ion H3O plus HSO4 minus. If it is that monoprotic, if it will more than 2 H plus ion will be released, so that H3O plus SO4 2 minus. So that's why on the basis of the reaction you can understand whether it is diprotic or monoprotic, diprotic, triprotic, or what is that. On the basis of how many H plus ions are released, on the basis of that you can say. So in this case you will see this is the triprotic H3PO4. H3PO4. So this first initially it release one H plus ion. So this area H plus ion first, and H2PO4 is second, and H2PO4 again another H plus is gone. So the second step, third step, another H plus will be gone. So all three H plus has released. So stepwise process, and it is not at a time. One bond breakdown H plus will go, second H plus will go, third H plus will go. All three will in the means say stepwise, first, second, third process. So in that this is triprotic in the nature. So on the basis of reaction you can understand. Okay, next. Then indicator. So it is actually that what happened usually in the chemical reaction we do not understand. It is through our naked eyes. Only we can see by using of indicator. As you know that indicator is a that's the most important role in the different kind of reactions. Indicator is most kind of that indicator has a role. So you have in the titration you have use that K-4 is a self indicator, right? K-4 is a self indicator. So that is not the issue. K-4, as you know that K-4 self indicator, when you add it to the oxalic acid to K-4, it will changes to the pink color. So self indicator, right? K-4. But it's methyl orange, methyl blue. If we use, these are the indicators. Phenolphthalein, these are the indicators. Okay, these are the indicators we are using in different kinds of that chemical reaction. So what is the role of indicator? Indicators are the organic substance, the presence of a very small amount of which indicates the termination of chemical reactions by change colors. So indicator is that which indicates that reaction is stopped. The once suppose the indicator is there, phenolphthalein is there, so if light pink that observed by your naked eyes, light pink observed, so that means you have to understand the reaction is stopped. Then you have to stop the titration there. So that is the work of indicator. Indicator shows that chemical reaction has stopped. Okay, only one drop of indicator if you add so into the reaction chemical, that is they will not take part in any kind of chemical reactions. They'll only indicate the changing in color. One concentration on that will give you the color, change in color. So that's why this is the most important of the Indicator is essential. So using of indicator is the most important thing. So that changes color. Indicators are of various types: acid base indicators, redox indicators, adsorption indicators, etc. So acid base indicators are organic substance. You should have to understand this one. If it is acid base reaction, you are doing the acid base reaction, so that should be organic indicator. And organic indicator, if which have one color in acid solution while different color in alkaline solution. In basic solution, one color will be there, like I told you, the phenolphthalein. So you can use in the basic solution or methylene blue, methylene red, orange. So whatever may be, that will have different color in different kind of a solution. Okay, so that you have to understand. The following theories have been put forward to explain the color change in the acid base indicator. So Oswald theory. So Oswald theory, what is that? Here ln means lon. So actually that ln means lon. So lon means ionized color. That is you have to understand. So this is the value indicating that things. So here the ionized color and the calculation base of that. So that HLN is equal to H plus and Ln minus indicator. You can say the indicator here. Ln is a value of that indicating pH things. If the indicator is free amine or substitute amine, the equilibrium is Ln H2O. If it is free amine, so Ln H2O is equal to OH minus and H Ln minus, Ln plus. Indicator acid base, acidic indicator, Ln, then it will react with the H plus. Okay, so these two things are, when combined together, dissociation in the H plus Ln ion indicator. Okay, ion minus divide that by H ion, so it's like a strength of dissociation constant. So by this you can use the pH. pH here, the value of pH is equal to log indicator divided by H indicator plus pK value. So that is the value of pH. So on the basis of that, you have to calculate the pH. So here the modern quinoid theory. So modern methyl orange, I told you methyl orange, what is the behavior of methyl orange? See that the composition is methyl orange, and here phenolphthalein. If you see the methyl orange, it has two parts. So nitrogen, double bond nitrogen is there, and left side there is Na plus O3, SO3 minus, and right hand side NCH3 whole 2. When it will cleaved from the nitrogen to nitrogen between that, due to the acid and base reaction, so that will be red quinoid will be formed. So that's why the methyl orange is used and red color will be gives. So phenolphthalein, actually that phenolphthalein is colorless benzoid form in acid, but it is red quinoid form in the alkaline solution. When the reaction changes acid to base, so reaction is acid to acid, strong acid to base reaction will be there. So then phenolphthalein will change its color in red color. So that's what is the change of that is role of indicators. Okay. Next, we will go to the color change of a range of indicators. You have see that things, a table is given. This table is most important for all of you. So you have to when you are doing any kind of experiment, you have to understand what type of indicator is used, what is the pH range, what color will be there in acid, color will be alkaline solution, and pK value. Okay, so if we'll see that methyl orange is there, the pH range is 3.1 to 4.4, and in acidic solution is red, and in alkaline solution is blue. And sorry, alkaline acidic solution methyl orange. Okay, alkaline solution is orange. So that means the difference between is 3.7. So these are the indicators what usually used. So methyl orange, cresol purple we will use, methyl orange, methyl yellow, methyl red, methyl red, then chlorophenol you have to use, then 4-nitrophenol you have to use, cresol you have to use. These are the frequently we use the what is that indicators in our experiments. Okay, select of indicator and indicator errors. So what is that? Select, how will select the indicator and indicator errors? So the primary consideration is choosing an indicator for a given titration is that the indicator should change, that the end point should occur within the required increment. So that means what is the role of indicator? That means reaction will be stopped somewhere else. Okay, so that's reaction will stop means the color will be formed. change in color will be observed. So that is what is the work of indicator. Then we can observe, we can stop, because that chemical, what is there in the chemical reaction is going on, we cannot observe. So indicator should be used. Okay, as a general rule, it may be stated that for a titration to be the feasible, there should be a change in approximately 2 units of pH or near the stoichiometric point produced by the addition of a small volume of the reagent. So that is the change, that is the think of that what you have use the indicator. But when the use of indicator along with the reagent, there might be an issue. So might be the reagent will not fit for with the that indicator. So we know that acid wet reaction, that what kind of that indicator we will use, that is we can understand. But thing is that when the reaction is there, the reagent is used, so reagent might have some reaction with the indicator, so there will be the error will be that occurred, that error will be, we can possess the error over there, right? So thing is that next, if you understand the thing, indicator errors. So the indicator errors follow from the fact that the indicator itself will consume a certain amount of the standard solution. So that means the indicator errors follows from the fact that the indicator itself will consume a certain amount of a standard solution. So that means, as you know, that will consume means it will react with some standard solution. So definitely there will be error. Okay, the amount of this consuming of standard solution depend first of all upon the nature of the indicator and the concentration. Okay, that means what type of indicator you are using, that indicator and the concentration will decide how much amount will be that particular sample will be used by the indicator. Then there will be the, what is that, error will be there. So that is the most important thing, whether it is alkaline for instance, or whether it is acidic, anything else. So that means you have to understand what type of that indicator you are using. So what type of what is the strength of the concentration of that particular solution. Then what will be the that is there any relationship between, is there any reaction between these two. Then on the over that you have to decide whether that indicator is having that any kind of error or not. So might be some error will be there in some indicators. So that is the thing. Okay, so these are the facts which is associated with this titration 1 method. And uh, we had to do this. Actually this is the theory, but most of the things are used in the practical. You have to understand that all the type of reactions, that titration reactions, that is whether it is strong acid strong base, or strong acid weak base, or weak acid strong weak acid strong base, or strong weak that strong acid and strong base, that on the basis of that you have to, or it's that polyprotic titration or something else. So you have to understand that one. On the basis of that you have to calculate. And pH also, pH meter has a great role in the particular titration, so you should be careful. Okay, I'll share this slide with you all. That is actually the slide is not perfectly working, so that's why I'll share these slides. So this is the titration 1. I have finished this one. Okay, some students have been kindly share this. Sir, screen is not visible. Okay, I have a network issue, so you please share this all slides in this session. Okay, so I'll as per the things I'll share. Yes. So that I will share all the slides later on. So thing is that, okay. If you come across this thing, so you'll get some questions. Uh, like this, only strong acids or a base is used as a titrant. Why? So you have to answer this one. Only strong acids or strong base is used as a titrant. Calculate OH minus of POH or pH at the percentage of ionization of 0. These are all the mathematical things. So you will calculate, and you will under the putting the values and all the things in the formulas. Just a second. Be online. Now we have to understand that is what is redox titration. As you know that redox reaction means it is oxidation hubs and reduction hubs should be there, and so there will be oxidation reaction as well as reduction reaction. So this is the simultaneously will be occurred. One species will go for the oxidation and another species will go for the reduction. So simultaneously which one will go for the oxidation and other will immediately will go for the reduction. So both are simultaneously happen. So that is redox titration. So you have well customized the redox titration in case of electrochemistry and all the things. Okay. So thing is that
Sir, Unit 9?
actually it's showing the unit like that, but I have to compare with the thing is that see that I am going through the titration, right? And the chapter actually on the basis of your syllabus it is unit 9 or unit 10 somewhere else, but I am starting that titration means I'll comparing with that one with the redox titration also, right? So you compare with the unit 9 or unit 10.
Okay, sir.
That's fine. But you will get the all slides. I'll share with you all slides. Okay, don't worry. So the that in this that is redox titration, a large number of analytical determinations make use of another important kind of titration, namely redox titration. As the name suggests, these titration are based on the oxidation. What I told you right now. So redox titration means oxidation and reduction titration. Okay, so this is actually oxidation and redox titration. On this, sir, what is the main motto of this one? What we'll find after this starting of this structure: define oxidation and reductions, explain in terms like electrode potential, cell potential, and redox potential. This is important area actually. The calculate the cell potential of a given cell, calculate the equilibrium constant for the redox reaction, and predict the direction of the reaction when it is what is that direction, what it is that a reactant to product or product to product to reactant, that will be calculated by that one. Construct a titration curve for the redox reaction and compute the equivalence point. These are the things we can understand. So now we have to understand actually the thing is that let me to explain what is redox reaction. So redox reaction has two parts as I said, that one is oxidation part, second is reduction part. Oxidation part generally we people understand that thing. If you ask a student that sometimes they told that oxidation is addition of oxygen and oxidation is removal of hydrogen, and oxidation is loss of electron, and oxidation is that is increase in oxidation state. All four things are known as the oxidation. All four more things are there, lots of things are there, but thing is that so these four things are mostly commonly used as the oxidation state, and from these at last two states, that is your loss of electron and increase in that oxidation number. So on the basis of these two things we have to understand the oxidation hub, right? If you go to the reduction, so reduction is the that is removal of oxygen, addition of hydrogen, and gain of electron, and decrease in oxidation state. These four things I told you as lots of things are there, but these four things are commonly we use for the reduction. So last two parts, that is what you say, that gain of electrons and as well as that is a decrease in oxidation number, these two are most important for the redox reaction. And addition of oxygen, removal of hydrogen, or whatever with the loss of that is removal of oxygen and addition of hydrogen, that's two things are, that is for the only for the organic chemistry, and there is no practical use in the physical and inorganic chemistry, right? So physical and inorganic chemistry only depends upon this loss of electron, gain of electron, or increase in oxidation state or decrease in that is oxidation number increase or decrease in oxidation number. These two things are most important. So see here the Fe2 plus gives rise to, in front of you, are you able to see the that okay, you are able to see, all of you able to see that the screen? Are you able to see the screen? Okay, so that means so thing is that if we see the screen, so Fe2 plus gives rise to Fe3 plus electron, one electron. That means in the reactant side, iron has 2 plus oxidation state. In the product side, iron has 3 plus oxidation state. That means oxidation state increases. When oxidation state 2 to 3, it means we said it is oxidation state increases. So if these things happen, this is, you can say it is oxidation. So oxidation of iron, increase in oxidation state. What I told you in the case of oxidation, that means Fe2 plus, here 2 plus is the oxidation state, and at the product side 3 plus is the oxidation state of iron. That means iron oxidation state increases. So if iron oxidation state increases, that means the reaction is oxidation reactions. Okay, if you go to the below, that is Cl2 plus 2 electron, then 2 Cl minus. So if we say Cl2 is a chloride ion and the chloride, so chloride having the oxidation number is 0 as is a molecule. So if Cl2 in the reactant side has a 0 oxidation state, and in the that product side, so that means Cl minus is there. So 0 to minus 1 is there, right? Minus 1 is there. So 0 to minus 1, the value decreases. So that means it is reduction. So that I told you. If oxidation number increases, that is oxidation. So if oxidation number is decreases from reactant to product, that is reduction. So you have to understand whether it is which species undergoes the, because when it, on the reaction we will put this one, which species undergoes the oxidation is increases, that oxidation number is decreases, you have to understand. Okay, if they say that near below, that is C selenium, that the thing is that C4 plus Fe2 plus in equilibrium condition, so double-headed arrow is there. So equilibrium condition C3 plus and Fe3 plus. Okay, now check it out. C in the reactant side, selenium has 4 plus oxidation state. In the product side, selenium has 3 plus oxidation state. So that means oxidation 4 to 3 value decreases, reduction. In the reactant side, so iron has that 2 plus is the oxidation state, and the product side iron has 3 plus is the oxidation state. So 2 to 3, reactant to product 2 to 3, that means oxidation state increases, that means oxidation. Okay, on the basis of this, you have to understand whether it is oxidation or reduction. So now redox. Okay, so I think that is the next part of redox reaction as two halves. So I told you already this one. So next, we have to stop today for this. After that, I'll start the redox reaction two halves in the next class. That means tomorrow, and you have to go through this one. So it's going to time is going to over. So thank you very much for your.
Thank you, sir.
Thank you very much.